Global warming can be compared to a house. We have the sun putting heat through the window into the house. We have the furnace putting heat out. When you have a heat pump. And the walls have insulation, different thicknesses as denoted by the yellow. Over here, like a house, we have the sun coming through the window of our atmosphere. And the furnace is like the core of the earth giving off heat. Now the heat pump is our oceans. And on a house, when the heat comes in through the window and the furnace gives off heat, the heat pump takes the heat in here and it takes it outside and gives it off to the outside air. Now, on our earth, it takes heat from the sun through the window and from the furnace, which is the core of the earth here. The heat pump is our water, which absorbs the heat and it lifts it up to the upper atmosphere near space, as denoted by stars and the moon. Now up here, it turns into clouds when the hot water vapor can't stay a gas and it gets cold. It changes form and it gives off heat, BTUs. When it goes from a liquid water to a water vapor, it's 970 BTUs per pound, and it's the same when it goes back. It absorbs heat. So the long story short is the hot water gas goes up to the upper atmosphere and turns into clouds, and when it does, it gives the heat off into space because it's very cold out here in space. Then all that very cold cloud falls back to the earth, bringing a lot of coldness because space is very cold and it's very cold up here, way colder than just freezing ice. It's colder than that, and it comes back to Earth, bringing additional cooling to the Earth. So with global warming, they say, well, if we make our atmosphere thicker so that its R value goes up by all the pollution we make, now more heat from the sunlight is going to stay in here instead of radiating off. So that means more water has to absorb the heat, carry it up here, turn into clouds, give the heat off into space, and then be subcooled, which is way colder than freezing, bringing the additional cooling back down to Earth. So not only does the heat disappear off the surface, but now the coldness of space is brought down to Earth. So that's why we have record cold temperatures when record amounts of heat make record amounts of water go up to the upper atmosphere where it decompresses and is also cooled. Then it changes form, which is a lot like what heat pumps do. So in here, when you put in more insulation and the furnace is still on and there's heat coming in from the window, well, the heat pump runs faster and faster and faster. And you're like, wow, that heat pump's running like all the time and running really fast. It goes faster and faster. Because now the heat that was going through the walls can't because there's more insulation. A lot like the heat that was going through the walls of our atmosphere can't because there's more insulation because we've changed the gases in our atmosphere to make them more insulative. It's like putting better gas in between the windows so that they don't let it heat out. But they do let the light come in. So that is why we're seeing record cold weather events and record hot events carry on, bigger and bigger hurricanes and tornadoes and snows and all that, because the record amount of heat is creating record hot and record droughts. But you say to yourself, well, what about when this heat comes up and it comes to this more insulative atmosphere, because it's more insulative now, what about all the heat that then can't go out this way, but instead is turned back this way? Well, not to worry. Instead of melting ice, the heat of the core melts more rock. And this rock then comes up here, carrying all that heat so the earth doesn't blow up. And it makes a volcano. And that smokes, and then that heat makes more ice melt, and the water absorbs it and takes it up into the air and takes it off to space. All good in that. But this increased heat retained in the core makes more volcanoes and more earthquakes. That's not so good. But that's how global warming works. We're not going to burn up because the more heat there is, the more water is going to be lifted to the upper atmosphere. And if there wasn't any, if all the heat just radiated off real nice through the atmosphere, there'd be no heat to lift any water, and it would all sit down here on the surface of the earth, and a lot of it then would freeze, and it would be totally out of the system because ice can't rise up into the air like water vapor, the gas, can. So it's taken out of the system. But if there's more heat, or the atmosphere is made thicker, like let's say every 12,000 years, the volcanoes boil over like a giant pressure cooker, replenishing the sky with a lot of carbon dioxide before the rains take it back down and put it in the ocean, which combines with shellfish to make limestone, meaning it makes rocks and takes it out of the atmosphere. We don't want our atmosphere not having enough carbon dioxide and other insulative carbon gases. So every so often, like a pressure cooker, our world goes off and sends volcanic gases out into the atmosphere. The only problem is that's every 12,000 years when nature does it. Now, with mankind, we've polluted our atmosphere to now we have an atmosphere that is so much like all the volcanoes going off. The world thinks, oh, it's time to retain a lot of heat and have wild weather just like the dinosaurs did. But of course, the dinosaurs were 90 feet tall. And the average person is about 5'6". Big difference when you're getting hit with hail and giant floods and rain and winds. If you're a 90-foot tall big dinosaur or a little tiny human being, it's not so good weather to have. But, so our mission in the future is to have our societies not change the R value of our atmosphere in ways we don't want it. Because right now we're changing it to have more insulation, and we don't want that. But of course, if it was here, which we might say is perfect, we wouldn't want to change our atmosphere to where it has less insulation, because that brings another set of problems. So we will have to make our cars and refrigerators and houses and factories make it to where we can make the atmosphere stay at the place where we want it to have this hydrodynamic, hydrological process, that means rainfall, the weather cycle, operate in a fashion that gives us nice amounts of rain and not too big storms and not too much snowfall, but enough of it, but not too much of it. So that's global warming, real simple. And of course, I was going to keep it real simple, but I tossed in a little more, but you'll get it, I'm sure. Okay, I'll see you soon. Bye.